Welcome all of you. In this video, you are going to learn about the unit number 1, electrical drives, fundamentals and dynamics. Okay. This is a outline of the presentations. It includes the introduction of the drives. So what is a drive? Drive is nothing but a motion control. Motion control, that is called a drive. It's nothing but motor plus controller, or simple to say fan plus regulator. Fan plus regulator, it is called a drive. Motion control, it's called a drive. Okay, it is a classification about the drive. What are the classification? So classification with respect to the motor, so AC motor and a DC motor. So AC drives and a DC drives. So DC drive is a record for a frequent maintenance needed because commutator is used. Okay, so another one is a limited locations. So that are the base it will going to classify. The next one. So this is about the concept of electrical drives. So classification. What is the concept behind about electrical drive? So electrical drive, the motion control. Why do you want to go for that motion control? Because the output of the drive is connected to the load systems. The load you are going to control. Okay. For example, overhead traveling crane. So the hook it will going to carry the boiler. That boiler you want to move from one place to another place. So with the help of the drive systems. The next one it is include for classification of the drives. What are the classification? Generally 3 types are there: group drive, individual drive, multi-motor drives. So like it is we're going to say about the classification of the drive. The next one, block diagram of the drive systems. So generally what type of blocks are there in the drive system? It's a simple source, power modulator and controller. Okay, and motor, load systems, sensing unit. So like about that one, these are the parts of the electrical drive. Then further what you will going to see, nature of the load characteristics. So what type of your load? Either your load is a constant torque load, or your load is a variable torque load. Okay, that means a torque is directly proportional to the speed you want, or torque is a square of the speed you want. Okay, directly proportional to the square of the speed you want, or torque is inversely proportional to the speed you want, variable speed do you want. So like about that load, what is our load characteristics? It should be match about the drive systems. So about that one. Okay, then next one is a motor load systems. What is a motor load systems? So motor produces the torque is a motor torque, and then load produces the torque is a load torque. So you will going to match about the motor and the load systems. So you will going to match or connected the motor and load. For example, electrical vehicle. The electrical vehicle is So the electrical vehicle, the load is act as about that one wheel. It will going to rotate on the forward directions. The motor it will going to connect it. How do you connect it? Either do you want a rotational motion you want, or a translation type of the motion where you want. So here motor and then the electrical vehicle need between that one is the translation type of that motion needed. So you will going to use for differential. So that a differential is taking place between the motor and the load. So that one, otherwise it's a gear method, okay, or a normal belt chain method is using. So effective method, when you will go to connect it, then only you will going to extend the life period of the motor. So reduce the speed, produce more temperature in the motor, it will going to reduce. The next one is a dynamic condition in electrical drives. So what are the basics of the dynamic condition of electrical drives? And one of the example about that one, 4-quadrant operation of the drive system: forward motoring, forward braking, reverse motoring and reverse braking systems. So that is about the example of the dynamic conditions in electrical drive systems. The next one is the stability of the electrical drive. What is the stability of the electrical drive? So due to the load oscillation or disturbance, the system is coming to the stable. So that is about the stability of the drive systems. So we're going to go with that some more deep. So motion control is about the drives, and it will going to applicable on that one. So transportation system, industry, rolling mills, textile mills, machine tool, paper industry, like about it will going to use on that one. And why we want to go for that electrical drives means it's a noiseless operation, flexible control, wide ranges of the torque and the speed control. So many advantages there for that. We are the reason to go for that electrical drive system. So our controllability is more. Then next one will go about the comparisons. So DC drives and AC drive comparisons. So while so power circuit and control circuit making about that one. Okay, it is about DC drive is the simplest one. AC drives is a complex one. So frequent maintenance is needed for the DC drives because of the commutator is take place. And the locations. So all location it will go to applicable for the AC drives operations. But at AC drives it will go to certain location will go to concentrated. So this is about the comparison between DC drives and AC drives. The next one is a block diagrams. So this is about the general block about the drives, the source, power modulator. It's a power modulator is nothing but a converter. So the converter maybe it is a power electronics converter AC to DC or DC to DC, DC to AC converters or AC to AC converters. So like about it will go to classification of the power modulator. Then next one is a motor. So with respect to the motor, either your motor is AC motor or DC motor. So with respect to your power modulator, you will go to select it. If for example my motor is a DC motor, then your power modulator maybe it is a DC output producer devices. So rectifier. So the source is what is the source? AC source, AC to DC. Suppose my source is a DC, then power modulator is a chopper. So DC to DC you will going to convert. DC to DC converter you will going to make it on that one. So like you will going to use about the power modulator. The power modulator it consists of that one power semiconductor device. That power semiconductor device you will going to control. Okay, controlling the pulse you will going to generate it with help of the control unit. Okay, for example you will going to take about that one is the electrical vehicle. The electrical vehicle source is a DC source, and then here is a motor, BLDC motor. Okay, then BLDC motor is connected to the wheel, and then you will go to the BLDC motor inbuilt. It is included in that motor itself. Hall effect sensor is there. The Hall effect sensor it will going to send the position. Okay, sensing that position to the controller unit. Based on the positions, okay, it will going to give the command. Okay, either the out of the three paces. Okay, out of the three paces, which two paces want to trigger at a time, either AB or the BC or the AC. So like it will go to trigger on that one. So like about the general block diagrams. So different type of the power converters you will going to use on that one. So based on your requirement, the power converter you will going to select it on that one. And the next one is the types of the electrical drives. So generally it is classified into the three types of the electrical drives. One is a group drive, second one is a individual drive system, third one is a multi-motor drive systems. So it's the simplest one. Group drive means 1:n. So only one motor, n number of the load, okay, connected to the systems. Only one motor, n number of the loads. Okay, so like about it is connected means through the belt arrangement, okay, you will going to connect it. So it is called a group drive systems. Individual motor drive means 1:1. Either the load is a load or the B load or the C load. So 1:1 you will going to connect it on the systems. Like about the lathe machine operations, you will going to perform on the individual drive systems, drilling machine or lathe machines, so type of the method you can use. So multi-motor drive system. What is multi-motor drive system? So n number of the load. So n number of the load you will going to use. So here is a n number of the motor, only one load. So here is a 1:n means here is a n for the load. Okay, here is what about that one? N:1. So where it is I have written, yes. So here is a n:1. So n:1. What is n for the n number of the motors? So best example for the traveling crane. So the traveling crane, what is the purpose here? The traveling crane. So it is a okay. I mean the hook it will go to moving up and down. Okay, another one is it will go to vertical axis traveling, horizontal axis traveling. So like about that one, it is needed for separate motor for each one. Okay, but what about the load? It will go to hook. That hook it consists of it will go to carry for that boiler. So like about that multi-motor drive, and then corresponding for the applications. You can see about the diagrams. So this is a diagram about that one group drive system. So what is a group drive systems? So only one motor, n number of the load systems. So only one motor. it is connected to that load. So load 1, load 2, load 3. So through the belt arrangement, it will go to connected to the load. So what is the drawback of this one? So only one motor. So if the motor is failures, this all the load it will go to idle. So you can't do use on that motor. So that's a problem about the group drive system. Individual means one to one. So either the one to one like you will go connected, or it is a part or B part or C part. So with respect to the motor operation, A part is working, and another one is a B part is working, like another one is a C part is working. So like the either A part is working of the load, or B part is working, or the C part is working. Otherwise you will going to connect it for that one separate individually you will going to connect it. Then next one is a multi-motor drive system. So only one load, okay, various of the motor, okay, different motor is you can connect it, or different type of the hoisting type, or it will go to forward and backward of the travel horizontal and cross sectional travels. So like about that one you will going to use. The next one will go for the selection of the drive systems. So why do we want to selection of the drive system? We want to see. We will want to develop about the small industry. So when we are going to develop about the small industry, we want to look at about the selection of the drive systems. So small industry will go to construct it. Okay, what type of the things we will go to consider under that one, we want to look at under one. So what is the source requirement? Suppose you have available for that rectifiers. So rectifier panel if you have available, that is your source. Then reliability. So what about that your reliability of the systems? So what about your space and then space available, and or it is the ground floor or the first floor, okay, like you will going to see. And what is your investment cost you have? So based on that your investment cost and requirement, so you can suggest the type of the drive system, group drive systems, or individual drive system you will going to suggest it. And environmental locations. Suppose the AC drive system it will going to operate for that any type of environmental locations. Suppose you will going to, especially for DC drives you are going to use means what type of the environment, whether the environment is surrounded for that dust and polluted oriented environment. So that type of the factors you want to consider. Then next two more characteristics you will going to include. One is a steady state operation requirement, another one is a transient operation requirement. So transient operation means it's similar to you will go to recap about the vehicles. So a vehicle consists of what is that one acceleration is doing and deaccelerations, okay, it will go to doing. So starting the systems and braking the systems, reversing the systems. So like about that one, these are the operation is come under the transient operations. And what about the steady state operations? It's include for the one speed torque characteristics. So what about the speed torque characteristics of your motor and the speed regulation, efficiency, duty cycle, quadrant of the operations. So these are the parameters coming under the steady state operation requirement. Okay, then continuations. Okay, same sources and the characteristics. So characteristics of the motor. So what is the motor characteristics? Okay, so starting characteristics. So starting characteristics you will going to look at about the starting characteristics. What is starting characteristics of the motor? Either you want to for that moderate starting torque or the high starting torque. So based on your needed. So starting torque of the motor, you drive system you will going to need. Then next one is a running characteristics. What about running characteristics of your motor? Okay. Or when you will going to apply for the load, if the load values increase, your motor is need to rotate on the constant speed, or your motor is some speed wave fluctuation also, is it okay? So like about that load is increase, speed is drastic, okay, normally load is increase means speed is a decrease, it's general control. So even though you want to rotate on the constant speed means you can go for that one constant speed motor, DC shunt motor or synchronous type of the motor. So what is the difference between DC shunt motor and the synchronous motor? So even if you will going to apply your load, the synchronous motor will try to rotate on the constant speed. But what about DC shunt motor? Drastically it will going to reduce the speed. Okay, when you are going to increase the load. The next one is a speed control characteristics. So you will go to speed controlling characteristics when you will go to either armature control method or field control method when you will going to apply. So what about that one characteristics and the braking characteristics you will going to look it on the drive systems. Okay, and based on your requirement you will going to select about the group drive or individual drive or multi-motor drive systems. And further some more points. So load, types of the load. What is your types of the load? The load is based to select on that one electrical drives. So you will going to select matching about that one your load with load under the drive systems. So load are classified in with respect to the torque characteristics. So load it is classified with respect to the torque characteristics. Okay, what is mechanical characteristics? Mechanical characteristics nothing but speed versus the torque. Electrical characteristics means what? Torque versus the armature current. Okay, the characteristics of the motor and the load should be matched. Okay, like you will going to select it on that one. The load is influence the choice of the electrical motor systems. So motor and the load should be matched on that one. Okay, motor for driving the machine is matching the speed torque characteristics of the given drive unit. So these are some more basic points. The next we will going to see about that one, characteristics. So characteristics. So what about the characteristics of the load? So your load is you needed a constant speed load. Okay, constant torque you want. For example, your application is a crane, hoist. So the type of application means you will going to need a constant torque with respect to the speed. Your load systems. Okay, or your load system is a variable torque. Variable torque or load required for that increasing torque with respect to the speed. So for example, your load is a generator type of the load. If I have generator type of the load means torque is directly proportional to the n. It is a needed linearly, it is increasing type needed. Suppose your load such as the fan type of the load. So whatever the fan type of the load means cooling tower fan, okay, cooling tower fan and cooling water pump, compressor, vacuum pump. So this type of the load if you are using means your load torque is torque is directly proportional to the square of the n you needed. So you will go to what is your load load characteristics. So you will going to look it about that one. Okay, your example based on that one. You will go to what is the your torque with respect to the speed. You will going to look based on that one. You will going to select about the drive systems. Suppose high inertia load I am using. High inertia load means you will going to select it about that variable speed type of the motors. So torque is inversely proportional to that n. So the type of the motor, for example, the AC series motor, and then if you are going to use for the slip ring induction motor for AC, you will going to select it. And some more general for selecting or choosing the or choice of the drive systems. The same we will going to display on that one. Same about that one. We will going to see about the diagrams. So torque is a constant torque systems. Okay. Or second one is a linearly increase or square of that is speed or variable torque. The next one is dynamic conditions. About the dynamic conditions, one of the example about the multi-quadrant of operations. So what is a multi-quadrant of operation? It is this is a things is showing. It's a very simplest one. Only 3 points will come to easy to remember. So speed versus the torque. This diagram is explained. It will go to show you 4 quadrant. Quadrant 1, 2, 3, 4. Both are also plus means forward motoring. Okay. Here is a 1 is minus, so forward braking. Both also minus or reverse motoring. One is a minus, that is called which one is minus? It's a positive torque, negative speed. So reverse braking. One is minus means braking system. Braking. Okay, speed. Both also forward, upward direction, both also forward. So that's why it is a upward motion. So upward motion is mentioned. So both also plus. So that's why motion is upward direction. So here is a both also downward motions. Why means it's a speed is a negative. So motion is a arrow mark is a downward direction. Motion is arrow mark is a downward directions. So upward motion. Why it is upward motion? Both speed is a positive. Both speed is a negative. Okay, both speed is a positive. Up, arrow mark is up. Arrow mark is down. So look at the arrow mark based on that one. First you will going to draw that speed directions. So same arrow mark directions. So you will going to you can draw for that one omega m. So how I will going to same arrow mark directions? It is a anti-clockwise. Both also same anti-clockwise. Similarly here is a downward direction. Downward direction means so clockwise over. So that's all over. The next one. The next point we're going to see. What is the next point in the diagram? You can look it about the diagram. So here is a load gauge I am using. Here is a load gauge is using. Here is a empty gauge. So load gauge. So load is a playing the role. Load is a playing the role. Here is a no load. So no load means which one is a playing the role? The counterweight is a playing the role. Okay. Counterweight is a playing the role. Okay. So you will going to second one is you will going to draw about the load torque. So the torque is taking place on the load side. Okay. So here is what about the load is used. So load is used means it's a pull down type. So load torque is this directions. Similarly, what about load torque is pull down? So this directions. So here is an empty gauge. So empty gauge means counterweight is a load. So this direction, that's all. The load torque is a, where is a load? It's a load, this is a load. So direction is a clockwise. Direction is a load side. So clockwise. Here is a, where is a load? The load is a, due to the empty, this is a counterweight is a load. Counterweight is load. So you will going to draw anti-clockwise. So this is a point number 2. Point number 1 is a speed, motion, upward direction, downward direction. Point number 2 about the load. So where is the load? So where the load side is a load torque is present. Load side is a load torque is present. Then next one, motor torque. Motor torque is one thing you will want to remember. Motor torque is always opposite to the load torque. So load torque opposite direction you will going to mention the motor torque. So load torque opposite, motion torque, motor torque. Load torque opposite, motor torque. Load torque opposite, motor torque. That's all. Only 3 points. So this is an example about that one, dynamic conditions. So your syllabus it is mentioned about that one, dynamic conditions. Okay. Then the load torque. Further point, the load torque. Load torque means what? The torque is taking place on the load. So generally it is classified active load torque, passive load torque. The load torque is included 2 more things. One is a friction and windage. So what is the active load torque? The active load torque. Active load torque is nothing but the potential to drive the motor under equilibrium conditions. So it will going to drive the motor. It will going to drive the motor under equilibrium conditions, even matched. So it is normally rotating. The rotating is called active load torque. So it will going to motor is coupled to the load. Motor is coupled to the load, and it will going to drive. So potential to drive the load. Okay. So with the help of that one motor, it will going to drive. So under equilibrium condition, it's a matched. It's normally working means that is called active load torque. So active load torque. Simple to say. You can see this is a motor. Motor is coupled to the load systems. So when the motor is rotating, the load it will going to rotated. If it is rotated means that is called active load torque. That's all. Okay. And then so this is the point you will note down. Then next one is a passive load torque. So what is the passive load torque? So load torque is which always oppose the motions, and it change their sign. So it is called it is a passive load torque. So always oppose the motions. Okay, and change their sign on the reversal of the motions. So it is called what about that one? Due to the friction and the cutting. So this is the conditions. It is opposing. So oppose the motions. So some conditions, abnormal conditions, when it is not an equilibrium condition, it will going to oppose the motions. So oppose the motion means automatically reversible sign. So change the sign on the reversible. So that is automatically negative signs. Then so further the load torque is included 2 more points. So friction torque, another one is a windage torque. What is the friction torque? It's nothing but a motor is connected to the load through the shaft. So that is shaft. That is a motor shaft. Okay, that is motor shaft. It will go to what you can say, some weight or that one reactions, that is called a friction torque. The friction will be present at the motor shaft. So that's good. So what is the windage torque? When motor runs, windage generate, a torque is opposing the motions. It's nothing but the machine. I will going to convert it into the generator operations. The machine is I will going to convert into the generator operations. So when I will going to convert into the generator operations, when the speed is increase above the rated RPM, automatically I will going to convert into the generator operations. So during the time, what will happen? Torque is produced. This torque is opposed to the motor torque. So that's why it is called a windage torque. When motor runs, when motor is runs, it will go to running. simple to say about that one, slope conditions, dynamic braking conditions. So dynamic braking conditions, when it will going to work when the motor drive on the hills place, top of the hills to the down of the hills. So during the condition, what will happen? The motor is runs above the synchronous speed. So it will working as a wind generates a torque. So this torque is opposing to the motions. So that is called a windage torque. So if you have know about the dynamic condition means you will going to learn about that one, windage torque. The next one, so motor load systems. What is motor load systems? So motor torque, the torque is take place in the motor. Similarly, torque is produced in that load. So you will going to connect it. How do you connect it? So are you directly connected or through that any devices you are going to connect it? So directly we are not connecting always. So we are going to connecting through that one. So energy transmission device. The energy transmission device may be gear systems, or you will going to use about that one step pulling or belt arrangement, or that differential. So the or switch gear. So the type of the method you will going to use. So if you have use means the energy is effectively transferred from motor to the load. That means avoid the overheat, overburden, it will going to avoid it. So that is nothing but a motor load system. That is nothing but a motor load systems. So generally about that one, the motor load systems, okay, it is about the variable inertia or the constant inertia. So this is the equation about the variable inertia. So variable inertia, this is about the equations. Then what about the constant inertia? Constant inertia means, so motor torque, it is equal to the load torque plus dynamic torque. Okay, load torque plus dynamic torque. So dynamic torque is present only in the transient operations, transient conditions. Yes. And further some more points. So here is a motor torque is either greater than or less than the load torque. So with respect to the acceleration, deaccelerations, it will going to depend on that one. It is a motor torque is greater than or less than the load torque. So large inertia, okay, if I have drive system, if I, for example, large inertia about the train. So train is running, it will going to train or the lift. If you want to lift, it will going to operate. It means the system already it is some load. Motor torque is needed for more. So motor torque is higher than the load torque. Then only it will going to move. Okay. So that type of the large inertia systems, always motor torque is higher than the load torque. It will going to design about that one. So next one, dynamic torque. So that dynamic torque, it will going to store in the kinetic energy. So already we are discussed about that one. So either the rotational motion or the linear motions. So what is the example for linear motion means? Electrical vehicles. So this is about the wheel and then motor. So how it is connected through the linear motion conversions. The next one is stability. So stability. So if we see that one, this is a motor torque and this is a load torque. This is a point. When I will going to change the load due to disturbances, I will going to change the load from here to here. The it will going to settle. Okay, settle to the point. So that is called a stable. See, stable the operations. It's settled. Best example about this ones. So whenever I will going to give the push on that one, it will move right as well as the left. The move right and the left. So it will going to equally, it will going to move on that one. So coming to the stable. So stable. And then here I will going to changing the load. Okay. So in that cases I will going to giving the disturbances. So disturbance in terms of the acceleration and the deacceleration. The point is it will going to like, see here is a motor torque and load torque. The point is not coming to that one coming to the same origin, means it is called unstable systems. So that's all about the first unit in that one. Yeah, and one more we'll going to continuation with the dynamic conditions. So a few more points it will going to covered in that one. So dynamic conditions. So dynamic condition are another name about the transient behaviors. So here Okay, few more points we will going to look it and about the ones. That's all. Thank you.